Hello everyone. So today I'm going to go through exercise 8.1. Okay, so let's run through question 17 first. So read the question together. So a circle touches the y-axis at the point 0, 3, and one of its intercepts on the x-axis is 9. So what is the equation of the circle? So in this case, right, we got to draw like a diagram lah, right, to kind of show us where, what does the circle look like. So I'm going to draw a diagram. So the diagram roughly is going to look like this. Okay, so it's not going to be drawn to scale, right? So something like that. So this is y, and then this is x. So yeah, they said that the circle touches the y-axis at the point 0, 3. So that means the circle only touch y-axis at one point. So this point is like 3 lah. So the coordinate is like 0, 3. Okay, and then one of its intercepts on the x-axis is 9. So there's two intercept, right? So one of them is 9. So I'm just going to label this as 9. Oh, sorry, 9. Okay, so the center will be around here lah. So usually because the circle touches the y-axis at one point, right? So that means the circle, the center will also be along this y equals to 3 line. So that's why for the center, we know that, right, the center, right, the coordinate is, the x we don't know, but the y is 3. Okay, so because the circle touches the y-axis at one point, so we definitely know that, the y part is 3. Okay, so for start, so how do we find, okay, so for example, in this question, they want us to find the equation of the circle, right? So of course, first thing, we need to find the center of circle. Okay, then second thing, we need to find the radius. Okay, and then of course, with this two piece of information, then it will allow us to find the equation. Okay, so yeah, so for this, in order for this to, like, how we're going to do is, right, we are going to draw a chord, right, that joins this coordinate and this coordinate, right? So this 0, 3, and for this, it will be 9, for this, it will be 9, 0. Okay, so for a chord like that, right, the perpendicular bisector, okay, the perpendicular bisector of this chord will always cut through the center of the circle. Okay, so this is one of the properties lah. So it will form a 90-degree. Okay, so yeah, so for this instance, we are going to find the equation of that black line. Okay, that is the perpendicular bisector, in order to find out the center of the circle. Okay, so in order to find out this black perpendicular bisector, we need to find the gradient of this red line, this chord. Okay, so how do we find the gradient? So the gradient, okay, let me switch back to red. So the gradient, okay, the gradient of chord, right, is equals to y1 y1 minus y2 over x1 minus x2. So it's negative 1/3. Okay, so therefore the perpendicular bisector of the chord will be -1 divided by -1/3, which will give us 3. Yep, just to double confirm, yes, it's 3. Okay, so that's the first thing we need. Okay, and second thing, we need to find out the midpoint of this in order to find out the equation of the perpendicular bisector. So we need the midpoint. So how do we find the midpoint? So midpoint of chord. Okay, so it will just be x1 plus x2 x1 plus x2 over 2, comma, y1 plus y2 over 2. So this is just 9 over 2, comma, 3 over 2. So this is the midpoint of the chord. Okay, so now we have the gradient, okay, the gradient of the perpendicular bisector, and also the midpoint of the chord, which also happens to be passing through the perpendicular bisector. So we can therefore create the equation of perpendicular bisector. Okay, so now for this, right, I'm going to change it to black. So perpendicular bisector, right? So y equals to 3x plus c. Okay, so we're going to sub in the midpoint. okay, the midpoint, which is 9/2, comma 3/2, okay, into this equation. So we will have 3/2 equals to 3 bracket 9/2 plus C. Okay, so after this, we will find out that our C is actually, okay, let me write it properly. Our C is actually equals to -12. Okay, so this is my equation. So the equation of the perpendicular bisector is y equals to 3x minus 12. Okay, so recall our center here. Okay, the center here has a y coordinate of 3. So how do we find the x part? We sub lor. So we sub y equals to 3 into this, into our perpendicular bisector. Okay, so we will have 3 equals to 3x minus 12, 15 equals to 3x, x equals to 5. Okay, so therefore, okay, our center is equals to 5, 3. Okay, so this is our center of the circle. Okay, so we're not done yet. So this is only the first part. Okay, the part number 1 on the top left of the screen. We only found the center of circle. Okay, so now I will erase the middle and I'll find the radius. Okay, because there's no space on the screen. Okay, so let me erase this. Okay, so we need to find the, what you call that? The radius, right? Okay, point number 2, radius. Okay, so let me just erase this first. Okay, we definitely need the center for sure. Okay, we need the center in order to find the radius of the circle. All right, so let's take a look. Okay, so now that we know that our center is actually, for this part, it's going to be 5, 3. Okay, so 5, 3. Okay, so if you take a look, right, our radius is actually 5. How I know? From the diagram you see, because here to here, right, is the radius, right? And for the y, the x is 0. For here, the x is 5. You all get it? So that's why the radius is going to be 5 units. Okay, so with this, we can come up with the equation of the circle. So I'm just going to use the standard form. Yeah, I'm just going to, okay, one of it. I'm just going to use, what do you call it? Standard form. Yep, yeah, I'm correct. Standard, sorry. So standard form, right? So x minus 5 bracket square plus y minus 3 bracket square equals to 5 square. Okay, so this is standard form. So so I just simplify 5 square. So x minus 5 square plus y minus 3 square equals to 25. So this is the equation of the circle. Okay, so yeah, this is it for question 17. Okay, let's go through question 18 together. So the center of a circle lies on the x-axis, okay, and its radius is 5 units. So a very unusual, I would say unusual circle lah. Okay, so given that the circle, right, the circle, okay, let me just get my pen. Okay, sorry. The circle passes through the point P, bracket 3, 3, find the possible equations of the circle. Okay, so first thing first, for circles, I will always visualize, right? So I'll draw a circle out, sketch, right? So I'm going to draw a circle. Yeah, just a quick one. Let's draw a nicer circle like that using technology. Okay. Okay, then we have our x-axis over here, so something like that. Okay, x-axis. All right, and then the center is on the x-axis, right? So let's label this as A. Okay, let's okay, let's let the center be A. Okay, and then this coordinate here must be A minus 5, and here must be A plus 5. Right, makes sense because the radius is 5 right? Anything to the left is minus 5. Anything to the right is A plus 5 because the radius is 5. All right. Okay, so then they say that also given that the circle passes through the point 3, 3. I don't know where's 3, 3. Let's just put it here. 3, 3. Okay, so ask us to find the possible equations of the circle. So from this, we know that, this A, right, this A, the value A, the coordinate of the center, right? So we can say let the center of circle be A comma 0. Okay, A comma 0. You want to use X comma 0 is fine with me as well. Okay, I just prefer to use A over here. All right, so we are going to, because since we know the radius, right? So, okay, of course, we need to find what is A, right? And a clue is given. What is the clue? The clue is the radius is 5 units. So we can actually form a length of line segment equation, right? Between the center, this center of the circle with 3 comma 3, and then equal it to 5 units. Okay, so what I'm going to do is this. So length of line segment, so square root, right? A minus 3 square plus 0 minus 3 square, it will be equals to 5. Okay, so length of line segment. So what is this? This is this. The length of from the center to 3 comma 3. That is the radius, right? Okay, so after this, I'm going to square both sides and also expand the inside, right? So when I square both sides, I will get rid of the square root on the left and I will add a square to the 5 on the right. Okay, and then I'll expand the insides together as well. So a square minus 2ab, right? Plus b square plus 9 equals to 25. So I cut short quite a bit of time. So a squared minus 6a, all right, this part will be 18 minus 25. So minus 7 equals to 0. So when I factorize it, I will be able to have a minus 7, a plus 1 equals to 0. So a equals to 7, a equals to negative 1. So look, we have two values of a. So that will allow us to find out two possible equations of the circle. Okay, so for a, okay, so I'm going to write for a equals to 7, comma, our equation of circle is going to be this, x minus 7 square plus y square equals to 25. That is for a equals to 7. How do I get this? Because of the standard form. Okay, the standard, the standard form of equation, which is what? X minus a square plus y minus b square equals to r square, right? Yeah, so A and B is the coordinate, A is the X coordinate of the center, B is the Y coordinate of the center. So for this question, the X coordinate for A equals to 7 is 7. All right, and then the Y part is 0. How come? Because it's on the X axis. So that's why you see a Y square over here. There's no need to write Y minus 0 bracket square. Don't need. Okay, then for the answer where we have a equals to negative 1, right? We will have, so for a equals to negative 1, comma, it will be x minus negative 1, so is plus 1. All right, square plus, same thing, y square. How come? Because the y coordinate is 0, so it's like y minus 0. So just write y square lah. Okay, y square equals to 25. Okay, I hope this is clear enough for everyone. So that's it for question 18. Okay, guys, let's go through question 19 together. So a circle passes through the points 2, comma 3 and negative 1, comma 6. Okay, so its center lies on the line 2x plus 5y equals to negative 1. So part 1, find the coordinate of the center of the circle. So let's draw, right? Let's sketch. So circle. Okay, and then 2 comma 3. So let's assume it's going to be here lah. Okay, so 2 comma 3, and then negative 1 comma 6. Let's see. Let's make it probably somewhere here. Okay, so here. Negative 1 comma 6. Okay, and then the center lies on the line 2x plus 5y equals to negative 1. So let it be. Okay, so the center will be I think I shouldn't draw the. Okay, maybe let's do it like that. Let's do it here. Yeah, I just want to make sure it doesn't look like the diameter actually. That's all. Okay, so this is the center. Okay, and then yes, the center lies on a line. Okay, so let's say the line is like that. Okay, so something like that. Yeah. Okay, so let's say the line is something like that. All right. So this line is called 2x plus 5y equals to -1. Yep. So they want us to find the what you call that, the coordinate of the center, which is this lah. So first thing first, we should know that this is a chord lah. So we can draw a chord line between these two. Okay. All right. And then we also should be aware that any perpendicular bisector of a chord will always pass through the center of the circle. Okay. So I'm just going to draw like that. So, okay, maybe a bit better lah. Something, okay, I shouldn't use red, right? Okay, let me use like orange. Yeah, something like that. Okay, so a perpendicular bisector will always pass through the center of the circle. So, okay, then as you can see, how to find the coordinate of the center is we are going to make use of what? Simultaneous equation. We are going to find out the equation of the perpendicular bisector, all right? And it cuts, or rather it intersect this 2x plus 5y equals to -1, right? So we can do simultaneous, all right, to find out the center of the circle. But the first thing is we got to find out what is the equation of perpendicular bisector. Okay, so before we start, we need to find out two things. Okay, so first thing is the midpoint. Okay, midpoint of the chord. Okay, second thing, we need to find the what? Gradient. Okay, gradient of chord, which will allow us to find gradient of the perpendicular bisector. Then after that, we can find the equation of the bisector. All right. And then after that, we can do simultaneous. So quite what you call that? Quite a lot of steps involved. Okay, so step one, find midpoint. So midpoint, okay, so midpoint is very simple, right? So we will have x1 plus x2 over 2, comma, y1 plus y2 over 2, right? Which will give us half, comma, 9 over 2. Okay, so this is the midpoint. All right, then what about gradient? So gradient of chord, so gradient of chord equals to, so y1 minus y2, so y1 minus y2 over x1 minus x2. Okay, so it's 3 over -3, which will give us -1. All right, so that means the gradient of the perpendicular bisector is equals to -1 divided by -1, which will give us 1. All right, so it means the equation, right, of the perpendicular bisector is y equals to 1x plus c. So I'm just going to write x plus c, and then you can sub in, right? You sub in the midpoint, right? You sub in half, comma, 9 over 2. All right, which then you can find out the c. So you will have so 9 over 2 equals to half plus c, right? So c is equals to 4. Okay, so c equals to 4. So the equation of perpendicular bisector is y equals to x plus 4. Okay, so now we got the equation of perpendicular bisector, right? We have the equation of the line, another line that passes through the center. So all we got to do is just to do simultaneous. Right, so I'm going to do the next part in red. So label this equation of perpendicular bisector as 1, and then this black line as 2. Okay, so I'm going to sub 1 into 2. All right, so 2x plus 5 bracket x plus 4 equals to -1. All right, so 2x plus 5x plus 20 is 4, not 14. All right, 20 equals to -1. So 7x equals to -21, x equals to -3. All right, then sub x equals to -3 into equation 1 again to find out what is my y. So y equals to negative 3 plus 4. So y equals to 1. Okay, so my center, all right, my center can be equals to negative 3, comma, negative, or not negative, sorry, negative 3, comma, 1. Okay, so this is the coordinate of my center, which is negative 3, comma, 1. All right. Okay, so I'm going to move on to the part 2. So find out the radius of the circle. So pretty simple. Let me see. Okay, so just give me a while. I'm just going to erase this. All right. So yes, we can find out the equation, the radius of the circle. We can just do the what you call that, length of line segment, right? With any other points that we have. We got 2 points on the circle, right? So we can just do a length of line segment from the center that we have just found with one of the coordinate that they give us lah. Okay, so basically, let's say we choose the negative 1, comma 6. All right, so part 2. So square root, right? So x1 negative 3 minus x2 bracket square. Okay, we should use square bracket over here, right? Plus bracket y1 minus y2 square, right? So equals to square root. This is negative 3 plus 1, so negative 2. So negative 2 square 4, right? Plus, so 1 minus 5. 1 minus 6 is negative 5. So negative 5 square root is 25. So 25. So equals to square root 29. Square root 29 units. Okay, so this is my radius. So the radius here is square root 29. All right. Okay, so now left the easy part. So actually, as you can see, right, the part 1 and the part 1 is the so-called the most tedious one. Part 2 is fine and part 3 even simpler because you got the part 1 and part 2 answer. And this is the 2 most important thing for you to form the equation of the circle, right? So you can form already lah. So x plus 3 square, right? And then plus y minus 1 square equals to square root 29. Then you got to square it again, right? Because the equation is r square, right? The formula is r square. So x plus 3 square plus y minus 1 square equals to 29. Okay, so just to recap, the formula is this. X minus a square plus y minus b square equals to r square. Okay, so in this case, because my r is square root 29, so my r is square root 29, so my r square must be 29. Okay, and then also for this, you'll be asking, how come this one x plus 3? Why? Because my a is negative 3. So that's why it's like x minus negative 3, which will give me x plus 3. Okay, so don't be confused, it's x plus 3 lah. Okay, it's not because I write the wrong formula. All right, okay, so this is it for question 19. Okay, let's go through question 21 together. Okay, so this is a so-called a better question lah. Don't need to draw any diagram, right? Diagram is given. Okay, so the diagram shows 2 circles, C1 and C2. So the center of C1, right, is P, 2 comma negative 2, right? And then C2 also passes through the point P. So that means C2, right, passes through the center of the circle C1. Okay, then the point Q, 6 comma 0, lies on both circles. Okay, and given that, all right, given that x-axis is a tangent to C2. So that means for C2 only, the x-axis at the x-axis is a tangent to C2 lah. And the point where it touches the C2, the circle C2 is at 6 comma 0. Okay, so part 1, find the equation of C1. So like I always say, you want to find equation of C1, you need the center of the circle and you need the radius. So for this one, very simple. How come? Because we have the center of circle already. We just got to find the radius. Why? What is the radius? Right? It's the length between PQ, P and Q. All right, so for part 1, very simple. I'm going to do it here on the left. So I just got to find PQ, which is my radius. Okay, because Q is also on the circle, right? P is the center of the circle. So of course I can find the radius, right? So the radius is just square root, right? x1 minus x2 square plus y1 minus y2 square. So equals to square root let's say this is -4 square, so 16 plus 4, right? So equals to square root 20. Okay, so square root 20 units. So they want us to find the equation, right? So same thing lah. So x minus 2 bracket square plus y plus 2 square equals to 20. Okay, so this is the equation for C1. Okay, part 2. Let's go on to part 2. So for part 2, they want us to find the equation of the perpendicular bisector of PQ. All right, so okay, so that means we got to first find out the midpoint of PQ. Okay, so we got to find out the midpoint of PQ, followed by the gradient of the PQ, which will allow us to find the gradient of the perpendicular bisector. Okay, so step by step, find midpoint of PQ first. So midpoint of PQ, okay, because let me draw the perpendicular bisector first. It's going to, because, okay, let me draw PQ first. So let's say I draw PQ like that. All right, my perpendicular bisector should look like the black line over here like that. Something like that. Okay, so we need to find, because the perpendicular bisector will always cut through the midpoint of PQ. Yeah, so that's why we are finding midpoint of PQ. Okay, so midpoint of PQ equals to, so x1 plus x2 over 2, comma, y1 plus y2 over 2, all right, equals to 4, comma, -1. -2 divided by 2 is -1. Yeah. All right. So that is the midpoint of PQ. What about the gradient of PQ, right? So y1 minus y2. So y1 minus y2 over x1 minus x2. So 2 over 4, which is half. Let me shift this somewhere here. Okay, so this is half. All right, so the gradient of PQ is half. So that means the gradient of the perpendicular bisector of PQ will be equals to -1 divided by half, right? Which is equals to -2. All right, so that means the equation of perpendicular bisector of PQ will be y equals to -2x plus c, right? So just got to sub in the midpoint that we have found, right? For -1 into equation. Okay, so we will have -1 equals to -2 times 4 plus c. So c is equals to 8 minus 1, which is 7. So the perpendicular bisector is y equals to -2x plus 7. Okay, so this is for 21 part 2. Okay, okay, so then now we need to find out where is the center of the circle of C2. So very clearly, if you see, okay, let's do it in blue. Okay, because Q is the tangent, right? Q at Q, right, it touches the C2 at only this point. So that means our center must also be along this line, right? So that means here is a center, and this is also going to be 6, comma, I don't know, right? This y part we don't know. The y coordinate of the center we don't know, but we can use the perpendicular bisector to help us, because the perpendicular bisector, right, of PQ will always cut through the center of the circle as well. So what we can do, we can sub, right, because we already know that the x coordinate, right, of the center of the circle is 6. So we sub x equals to 6 to find the y. Okay, so this is for part 3. So sub x equals to 6, okay, into the perpendicular bisector. All right, so y equals to -2 times 6 plus 7. So equals to -12 plus 7 is -5. Yeah, all right. So therefore, my center of the circle is actually just 6, comma, -5. All right. Okay, so now final step. We got to find the what? We got to find the radius again. Okay, because for part 4, we need to find out the equation of C2, right? Okay, So that means we got to find out the radius as well. So radius how? Okay, actually don't really need lah in this case, because if you look at the diagram, the y is -5, right? And then the top first, the highest point is at 0, right? 0 is the highest point, then you go down by 5 units, so you reach the center of the circle at -5. So that means the radius is 5. Okay, so the radius, so for part 4, okay, maybe I need to use this. Okay, so for part 4, right, the radius is equals to 5. All right, so the equation of circle can already lah. So x minus 6 square plus y plus 5 square equals to 5 square, which is 25. Okay, so this is the equation of C2. All right, so I know there's a lot of things going on, right? So maybe you can slow down, or you can relook at the video to see what I'm saying, because there's a lot of things going on, right? Like for example, the perpendicular bisector of PQ, right, will always cut through the center of the circle. So this is like a very big mouthful to digest and understand. So maybe you need to rewatch the video a few more times lah, to make sure that you catch what I'm saying. Okay, because it's really a lot of things to take note and to remember and to think about. Okay, so this is it for question 21. Okay, let's go through question 23 together. So diagram is given, so very good. So in the diagram, the circle with center C, right, passes through the point A, which is 1, 7. So this circle passes through this coordinate here. And then it also touches this line, right, this line at B, right, which is B, as in at B, which is 8, 0, right? So it only touches at this point. So find the equation, right, of the line B. Oh, sorry. Find the equation of the line BC. All right, so very simple. So how do we find the equation of line BC? So always take note, because C is the center and B is like, the point where it only touches like at a tangent, right? So that means this is like a what? A radius, and this is a tangent. So it's like tangent perpendicular to radius. So in fact, we are actually finding out the what? It's not a perpendicular bisector, because we don't know whether this this radius cut through the tangent at half, right? But we do know that this is perpendicular, right? Because it's tangent perpendicular to radius. All right, so if we have this, if we know about this condition, right, means we can actually find out the gradient. All right, how? Because we can find out the gradient of this equation, and then we can find out the gradient of the radius. All right, so the gradient of this equation is, we just got to rearrange it, right? So 3y minus 4x equals to negative 32. Then 3y equals to 4x minus 32. Then y is equals to 4 over 3x minus 32 over 3. So that means the gradient, all right, the gradient of this line, gradient of tangent, let's call this because this is a tangent line, right? So it's equals to 4 over 3. All right, so the gradient of the perpendicular, right, will be equals to -1 divided by 4/3, which will be -3 over 4. Okay, so that is the gradient of that radius. All right, so that means now we can have an equation. So y equals to -3 over 4x plus c. And since b, right, 8, 0 is on the radius as well, so sub it in to find out what is our c. So sub, right, 8, 0 into the equation. All right, then we will have 0 equals to -3 over 4 times 8 plus c. So c is equals to, let me do some calculation. So c is equals to, hold on, 4 negative 12, is it? Is it 12? Wait. No, not 12. My bad. It's 6. I think I'm tired already. So because 4 and 8 can cancel, become 2, right? So -3 times 2 is -6. And I bring it over, so it's 6. Sorry, it's not 12. Yeah. But anyway, so that therefore y is equal. Whoa, sorry. Okay, so therefore y is, Okay, sorry. Therefore, y is equals to negative 3 over 4x plus 6. So this is the equation of line BC. Yeah, which is also the radius lah. Okay, so that is the part 1. Okay, let's move on to part 2. So for part 2, find the coordinate of C. So let me just erase all this. So how do I find the coordinate of C? Okay, so in this case, we might have to form, we might have to involve like using radius lah. Okay, because we got to use A as well, right? So because we, okay, so anyway, because BC, right, is, the equation of BC is y equals to negative 3 over 4x plus 6, right? So let's say I let, okay, the x coordinate, okay, of C be A. Okay, so that means the y coordinate, right, the y coordinate will be equals to what? I got to sub lah, right? Okay, what do I mean? Let me, maybe I say, but okay, so if I let the x coordinate of C be A, right? So I will have to sub x equals to A into my BC, my equation of BC, equation BC. Okay, to find out what is my y, to find out lah, but no value, no numbers yet, but I just finding out in terms of A. So that means like y is equals to negative 3 over 4A plus 6. So that means for C, my center, I can temporarily write this A, comma, negative 3 over 4A plus 6. This is my coordinate for now. Okay? Can okay, then I'm going to erase the red because I need some more space. So if you need the answers for the red part, please go and, rewind the video again. All right, just simply, maybe my handwriting too big lah. So too much things to write also lah. Okay, so yeah, I'm going to write it on the right side now. So yes, so after doing this, right, I know that, because AC is the radius, right, and CB is also going to be the radius. So these two must have the same length, right? So I'm going to equal them together. Okay, so first thing first, what is AC? So how to find the length of AC? So length of line segment formula, right? So A minus 1 square plus negative 3 over 4A plus 6, right? That's the Y, minus 7 square. All right, then I simplify it lah. So A minus 1 square, okay, plus this is negative 3 over 4A minus 1 square. Okay, that's AC. Then for BC, it will just be equals to square root, right? So A minus 8 square, right? Plus negative 3 over 4A plus 6 minus 0 square lah. So don't need to write. So bracket square. Okay, so yeah. So then I can just equal them and solve for A lor. Okay, so I'll equal them. Okay, I'll equal them. Now the working is going to be way longer lah. So I'm just going to equal them. And solve for A. Okay. Hold on, I'm just writing out. I'm like repeating the steps. Yeah. Okay, so now after this, what do we do? Square both sides lor. Right, and then expand out everything lah. Okay, so by right, you are supposed to get the A value lah. Okay, so let me take a look. So, okay, square both sides, right? So you'll get rid of the square root. So expand out individually now. So A square minus 2AB plus B square, right? Plus, so this one also A square minus, A square plus 2AB plus B square. So 9 over 4A square, right? Plus 2 times 3 over 4 times 2. So is 3 over 2A, then plus 1. Okay, equal A square minus 16A plus 64. Okay, then for this part here will also be, okay, so plus 6, right? So A square plus, no square there. A square minus 2AB plus b squared. Wait, let me write. Okay, minus 2 times 6, 12, 12 and 4 cancel 3. So minus 9a, okay, plus 9 over 4a squared. Yeah. Okay, so as you can see, quite messy lah, huh? So, okay, so this is on the left, this is on the right. So as you can see, both sides got a square, both sides got 9 over 4a square. Okay, so I'm just going to simplify, I'm just going to remove them. Then I will have this negative 2a plus 1 plus 3 over 2a plus 1, right, equals to negative 16a plus 64, right, plus 36 minus 9a. So I just got rid of all the a square. Okay, so now just do some simple calculation, add up the a, right? So negative 2 plus 1.5. So we have negative half a plus 2 equals to, right? So negative 25a plus 100. Okay, so just bring things left and right lah. So 25 minus 0.5, so 24.5. 24.5a equals to 100 minus 2, which is 98. All right, so a is equals to 98 divided by 24.5, which will give me 4. Okay, finally, so my a is actually equals to 4. Right, so that is the x coordinate of C. So what about the y coordinate? So the y coordinate, here, the y coordinate will be equals to negative 3 over 4 times 4 plus 6, which is 3. Okay, so therefore my C is 4 comma 3. Okay, so this is the center of the circle, right? 4 comma 3. Okay, lastly, let's go on to the last one, number 3. So now we have center, right? Do we have the radius? Okay, we can find lah, right, with one of the formulas there. Okay, so let's just find the radius lah. Okay, so the center, okay, just going to say the center here, maybe write out in red. Okay, so the center is 4 comma 3. The radius is what? So the radius is equal to square root, right? Let's do it with a lah. So 4 minus 1 square plus 3 minus 7 square. So equals to square root 9 plus 16. Yeah, okay, so equals to square root 25, which is 5. Okay, so therefore the equation of the circle is x minus 4 square plus y minus 3 square equals to 5 square. Or rather, you should write as 25 lah. Okay, so that is the final equation of circle, which is very easy lah, once you get the center of the circle and the radius. Right, so that is the final answer, and this is it for question 23.